One of the central dogmas of chemistry and science is something that you've probably heard before, that mass is conserved. Meaning, it cannot be created nor destroyed. Can't make mass, can't destroy mass. Has to go somewhere. We can see that in chemistry in chemical reactions. One reaction that you have done before is magnesium solid, so magnesium metal, mixed with HCl. Let's examine the particulate model of this so that we can write a chemical equation. So here I have magnesium solid, represented by my gray block here, with 2 valences, and I have my HCl, which we have our chlorine on top and our hydrogen on the bottom. And if these do a reaction together, they will make magnesium chloride, hydrogen gas. As you've seen in the particulate model, magnesium will react with HCl, hydrochloric acid, which is aqueous. As we've seen in the lab, it's dissolved in water. And that will form magnesium chloride, which is also aqueous, which we can find on our periodic table, and hydrogen gas. Let's talk for a minute about hydrogen gas. Hydrogen gas is a special element in that when it's on its own, just hydrogen, it exists as what's called diatomic. Diatomic meaning 2 atoms. Hydrogen must exist as a diatomic when it's on its own. So whenever you just produce hydrogen gas, it will always get the subscript of 2 because that's how it exists. There are other diatomic elements as well. You can find those on your periodic table. If you look on the periodic table, you'll notice that some of the elements are shaded in. They're this darker gray color. Those elements are diatomic. We call these the Magnificent Seven. Anytime that hydrogen is on its own, just hydrogen gas, it'll be H2. Anytime that nitrogen is on its own, as nitrogen gas, it will be represented as N2. That means that 2 nitrogens are bound together. These lines here just represent bonds. Hydrogen makes 1 bond to another hydrogen. Oxygen gas will exist as a diatomic as well. It's shaded. Same with fluorine, chlorine, bromine, and iodine. All of these exist as diatomics. These are our Magnificent Seven. So anytime in a chemical reaction where you produce one of these 7 things, you must have a subscript of 2 to represent that it is existing as a diatomic element. In contrast, anything else on the periodic table exists as a single element. So if you have elemental lithium, it's just lithium on its own. If you have elemental carbon, it's just carbon on its own. If you have elemental sulfur, it's just written as 1 sulfur on its own. It doesn't make bonds to anything else. So it's just those shaded in ones that are special that get the subscript of 2. So when we say that mass is conserved, that means if I add up the mass of everything on this side of the chemical equation, so all of the reactants that I put in, it should equal the mass of all of the products because the mass can't go nowhere. When we take magnesium and HCl and put them together and we rearrange them and make new elements, all of those atoms have to be accounted for, and so does their mass. So we can check this by adding up the mass of all of our elements. So 1 magnesium weighs 24 grams. 1 hydrogen weighs 1 gram. And 1 chlorine weighs 35 grams. If we add all that up together, we get 60 grams. And then we can do the same on the other side. If we have properly represented our chemical reaction here in our chemical equation, then the mass on the product side should also be 60. That's how we know mass has been conserved. So 24 plus 2 chlorines, so that's 35 twice, plus 1 gram for one hydrogen and 1 gram for the other hydrogen. And if we add all this up together, we end up with 96. So you may be asking yourself, why aren't they the same? And this has to do with the fact that I have not balanced my chemical equation. I have not accounted for all of the atoms. You may have noticed that on this side of the equation, I'm representing 1 hydrogen and 1 chlorine. However, on the product side of the reaction, I have 2 chlorines and 2 hydrogens. I have to make it so that the atoms and molecules on one side of the equation are equal to the amount on the other side of the equation. That's called a balanced chemical equation. Because if I'm going to end up with 2 chlorines over here and 2 hydrogens over here, they have to come from somewhere over here. I can't just make them up out of nowhere. So we balance with something called coefficients. These numbers go in front of the molecules, and they tell me how many of the entire molecule that I'm using. So right now, if there's nothing written, it symbolizes that there's 1. So technically right now I've got 1 of each of these molecules. However, based on what I have on the product side, I need 2 chlorines and 2 hydrogens. Right now I only have 1 of this entire molecule. So to make this a balanced chemical equation, I will need to make this a number 2. What that 2 says is I have 2 of everything here. You don't want to change the subscripts. For instance, write H2Cl2. Don't do that, because that's saying you're changing the bonding, which we're not doing. All I'm saying is that I have 2 separate HCl molecules a part of this reaction. So I'm going to show that now with the Legos. So we've seen that the mass is not conserved and that we have to balance our chemical equation. And so I'm going to show you what that looks like with the Legos. As you can see here, the magnesium has 2 valence that must be filled. My hydrochloric acid splits apart, and my chlorine will attach to the magnesium. That's to make my magnesium chloride here. But if I just do it in a 1-to-1 ratio, you'll see that there is a valence spot open for on my magnesium here. You'll see that there's a valence spot open on my magnesium here, which means in order to properly do this reaction, I will have to use 1 more HCl. So I have 1 more HCl, and those break apart. My chlorine attaches to my magnesium here, and now my magnesium valences are satisfied. That's my magnesium chloride here. And I have enough hydrogen to make the diatomic hydrogen elemental form, like so. And so in order to do this reaction properly, you need a 2 in front of the HCl. All that's saying is that I have 2 individual HCl molecules, just like here. It doesn't mean that they are all mushed together. It just means I have 1 HCl molecule and another HCl molecule. So now that I've balanced my chemical equation, we can redo the mass on the reactant side. This is the reactant side. This is the product side. These are all the things I start with. These are all the things I end up with. So I can redo the mass on the reactant side and hope that we get 96. So I still only have 1 magnesium, so 24. But now I have 2 HCl molecules, meaning I have 2 hydrogens. So that's 2 grams total. And I have 2 chlorines, 35 and 35. Have to account for both of them. Now when I add them all together, I do get 96 grams. And my mass is conserved. From one side to the other, from reactants to products, all of the mass has been accounted for. When you're balancing chemical equations, conservation of mass can help you verify that you have properly balanced your chemical equation.